Welcome back to the AI interview questions series for Java developers. In part 1, we covered AI fundamentals. In part 2, we discussed LLMs, tokens, context windows, and how LLMs generate responses. Now, in part 3, we will move to some of the most important concepts used in modern generative AI applications, like embeddings, vector databases, and semantic search. These concepts are especially important because they form the foundation of RAG, Retrieval Augmented Generation. Let's begin with question 17. What is an embedding? An embedding is a numerical representation of data. It converts text, images, audio, or other types of data into a list of numbers called a vector. For example, imagine we have this sentence: Java is a programming language. An embedding model converts this sentence into numbers, and the final vector may look something like 0.21, minus 0.45, 0.78, something like this. In reality, embeddings may contain hundreds or thousands of dimensions. The important point is that similar meanings are represented by vectors that are close to each other in vector space. For example, Java is a programming language and Java is used to build software applications, have different words, but their meanings are similar. Their embeddings should therefore be relatively close to each other. This allows computers to compare meanings mathematically. Why do we need embeddings? Computers cannot directly compare the meanings of two sentences in the same way humans do. For a human, these two sentences are clearly related. How do I create a Spring Boot application and how can I start a new project using Spring Boot? The words are different, but the meaning is similar. Embeddings convert both sentences into vectors. Now the computer can mathematically compare those vectors. If the vectors are close to each other, the meanings are considered similar. This is extremely useful for semantic search, recommendation systems, RAG, document search, duplicate detection. So, embeddings act as a bridge between human language and mathematical computation. What is a vector? A vector is simply a collection of numbers. For example, 0.2, zero point 0.8, minus 0.4, zero point 0.7. This is a very simple example of a vector. An embedding model creates a much larger vector containing hundreds or thousands of numbers. Each number represents some aspect of the data's learned representation. We don't manually decide what each number means. The embedding model learns these representations during training. The important thing is that similar data points tend to have similar vector representations. For example, Java tutorial may be closer to Spring Boot tutorial than to cooking recipe because the first two are semantically related. What is a vector database? A vector database is a database designed to store and search vector embeddings. Traditional databases store information like ID, name, age, city. Vector databases store something like document plus embedding. For example, document. Spring Boot is a Java framework. Embedding will be 0.21 minus 0.45, 0.78. When a user asks a question, the question is also converted into an embedding. The vector database then searches for stored vectors that are mathematically similar to the query vector. This is how semantic search works. How does semantic search differ from keyword search? Let's compare keyword search and semantic search. Suppose a document contains Spring Boot simplifies Java application development. Now the user searches, how can I create a Java application easily? A keyword search may not find this document because the exact words don't match. The document says simplifies Java application development, while the question says create a Java application easily. Semantic search understands that the meanings are related. It compares embeddings instead of simply matching exact words. This is why semantic search is much more powerful for natural language applications. What is similarity search? Similarity search means finding vectors that are closest to a given query vector. Let's imagine we have three documents. Document A that contains Java Spring Boot tutorial. Document B, Python data science course. Document C, Spring Framework guide. The user asks, how do I learn Spring Boot? The question is converted into a vector. The vector database compares it with the stored vectors. Document A may be the closest match. Document C may also be relevant. Document B may be far away. The system returns the most similar documents. This is the core idea behind vector similarity search. RAG stands for Retrieval-Augmented Generation. It combines information retrieval with large language models. The basic process is first the user asks a question, the question is converted into an embedding, the vector database searches for relevant documents, those documents are retrieved. The retrieved information is added to the prompt. Finally, the LLM generates an answer using that context. The important point is that LLM does not need to know every piece of information during training. We can provide relevant information at runtime. Embeddings are one of the most important components of RAG system. Imagine a company has thousands of documents. We cannot send all of them to the LLM for every question. That would be expensive and inefficient. Instead, we create embeddings for the documents and store them in a vector database. When the user asks a question, we create an embedding for that question. Then we search for documents with similar embeddings. Only the most relevant documents are sent to the LLM. This makes the system more efficient and helps the model answer using relevant information. This is the complete flow. Before the user asks a question, we prepare our documents. First, we split large documents into smaller chunks. Then we create embeddings for each chunk. These embeddings are stored in a vector database. Now the user asks a question. We create an embedding for that question. The vector database searches for similar document embeddings. The most relevant chunks are retrieved. These chunks are added to the prompt. Finally, the LLM uses this context to generate the answer. This entire process is called RAG, Retrieval Augmented Generation. Let's quickly revise today's 8 questions. An embedding converts data into a numerical vector. We use embeddings to compare the meaning of data. A vector is a collection of numbers representing data. A vector database stores and searches embeddings. Keyword search looks for exact words, while semantic search looks for meaning. Similarity search finds the most similar vectors. RAG retrieves relevant information and provides it to an LLM. And embeddings are important in RAG because they help us find the most relevant information from large collection of documents. Today we covered questions 17 to 24. These concepts are extremely important for modern AI application and especially for RAG systems. In next video, we will discuss interview questions about prompt engineering. We will cover zero-shot prompting, one-shot and few-shot prompting, system prompts, user prompts, and how to improve the quality of LLM responses. If you are preparing for AI interviews as a Java developer, make sure you understand both the theory and the complete application flow. I'll see you in the next video. Thank you for watching.